An airline knows from experience that the distribution of the number of suitcases that get lost each week on a certain route is approximately normal. Again, buzzword here, approximately normal, which means we can sketch a curve to help us. The mean is 15.5, so that is in the middle, with a standard deviation of 3.6. What is the probability that during a given week the airline will lose less than 20 suitcases? So the probability of less than 20, this is just like number 18. We're going to convert 20 to a standard score, so it's x minus the mean divided by our standard deviation. We get 1.25 as our z-score. And then to find our probability, we do normal CDF, negative 10 to 1.25. We get to 4 decimal places, 0.8944. Again, the picture will help you because we know that we've shaded more than half of the curve, so we definitely need an answer that is larger than 50%. Okay, number 20. We have the same information as number 19. So we have a normal distribution. The mean is 15.5, but it wants you to find Q1. So that would be the number of suitcases that marks the 25th percentile. Remember, percentile means equal to or below, so we're shading the bottom of the curve. In here, we're solving for x. So our mean is 15.5. We know our standard deviation is 3.6, which means we have to be able to find z. When we have area under the curve, especially the bottom, we use the inverse norm. The inverse norm reads the bottom of the curve, so we don't have to change anything, change any signs or anything like that. So the inverse norm of 0.25, we get negative 0.67. Now we're going to take that negative 0.67 and multiply by 3.6. Then we add on our 15.5, and we can say about 13 suitcases. The next part says find the third quartile. So we know that this is the 75th percentile. So our answer, we know, has to be something greater than 15 suitcases. So 2 ways to find z. 1, we know our curve is symmetrical. So there's 25% left at the top of the curve, so I know that the z-score is 0.67. If you forget, it's not a big deal. Just do the inverse norm then of 0.75. Into 2 decimal places, you're going to get 0.67. Okay, so now we take that 0.67, and this time we multiply by 3.6. We're going to get the same answer as we did before, just positive. Then we're going to add our 15.5, and we're going to get 17.912. So we could say about 18 suitcases. 21. Assume that the heights of women are normally distributed with a mean of 63.6 inches. So 63.6 is our average, that's in the middle, with a standard deviation of 2.5. If 100 women are randomly selected, find the probability that they have a mean height greater than 63 inches. So here's 63. We're looking at greater than. But we're finding the probability of a mean being something. So when we convert this to a z-score, it's not x, a data entry. It's a sample mean. So this is the equation that we're using to convert 63 into a standard score. Okay, so in your calculators, if you're going to do this as one calculation, you're going to need parentheses around your numerator and parentheses around your denominator. I know that the square root of 100 is 10. I'm just going to type in 10. And we get that z is negative 2.4. So now to find that probability, we do normal CDF, negative 2.4 to 10. Okay, again in your calculators, we go to our distributions, normal CDF, negative 2.4, comma 10, we get 0.9918. 22. From past experience, 65% of target customers use their credit card to pay for their purchases. A random sample of 250 customers is selected. Using the normal distribution with z-score would be used to find the probability that at least 180 customers paid with their target card. So the probability they used their target card is 0.65. We have a sample of 250. We're looking for the probability of at least 180. This is a binomial probability. However, we can't use binom CDF or 1 minus binom CDF. We have to use the normal curve because it says what is the z-score. So we're not even finding the probability. But in order to use the curve or think about using the curve, we have to actually calculate our mean, which is n times p. So it's 250 times 0.65. And we get 162.5. We should also calculate our standard deviation, which is the square root of n times p times q. Remember, p and q together equal 1. So q is 0.35. And we get 7.542. So now let's see, it says at least 180. So 180 is over here. At least means we want to include 180 and shade to the right. Remember, in these we have the correction of continuity. We're going to change x by 0.5. We want to make sure that we include 180, meaning we shade over it, when we change it by 0.5. So we're going to change this to 179.5. This way when I shade, I'm shading over 180. If you changed this to 180.5 and shaded to the right, you would not be including 180. So to find that z-score, we do our x minus the mean divided by the standard deviation. The key here is that we don't use 180 for x, we use 179.5. Okay, so we get 179.5 minus 162.5 divided by 7.542, the standard deviation that we calculated, and we get that z equals 2.25.